Okay, so welcome to this drawn video on the 20 higher level question C3. Okay, so surface geometry. Now it's based on a watch there. So the image on the right, design includes transition pieces connecting an octagonal base, so 8 sides, okay, to a square watch face. Figure C3 shows the elevation, plan and end view, okay, of a similar watch, and a partial surface development has been shown. Part A, draw the given end view. So that's a hint to draw the end elevation first. Then project a plan. So on project a plan, so that's number 2. Okay, and 3, draw the elevation. Now, it's 60 degrees off vertical there, so the base is at 30 degrees. Okay, the scale is 4:1 in a large scale, so we have to multiply everything by 4. So 15 by 4 is 60, 7 by 4 is 28, 8 by 4 is 32, 5 by 4 is 20, okay, 40 there, and that's 40 there as well, and 10 by 4 is 40. Okay, so I'm going to draw my XY line in, and I'm going to draw my end elevation. Okay, so it's a vertical face here on the side, 10 high, so that's going to be 40 high, and then on the bottom, okay, it was 60, 28 and 32, that's 120. So I'm going to draw a line at 120 degrees, or sorry, at 30 degrees, 120 long, and on the top it's 40 and 40, so them added together is 80. You can connect them together. Okay, then along the bottom, alright, 8, so there's 8, that's 32. Okay, plus 28 is 60, and then the same on the far side. So there's my center line, and there's one of the faces there drawn in. There we have, there's our end elevation complete. Just want to draw in a YY line. Now, the next thing we have to do is draw the plan view. And before I draw the plan view, I'd be labeling these points. Okay, so I'm going to call that A, B, C, B/C, D. So there's point D. If you were wondering where exactly point D is, okay, what you could always do now is, alright, on your exam booklet, okay, you could just be using it to help you judge, okay, where points are, but I wouldn't be don't even think about measuring anything off it. Okay, D, E/F, so there's E, F, okay, G/H, so G, H, I/J, and then K/L. Now, down in plan, okay, now again, this would be used to help you, alright, on your exam booklet. You could be doing this to help you figure out which point is which, because they're not easy to figure out for some students. Some aren't going to find it easy. Now, which one am I? Oh, sorry, I drew that 45 degree line there in the wrong place. So there's obviously going to be K and L. there's going to be point D. So anything on the top face, like this is going to be B and C, alright, and it's a square face there, and then the outside is the octagonal base, which is the bottom, and you can see B and C here when you bring them down, okay, and across, that's where you're going to get them. That's point A. Then this is I/J here, or I and J, and then G and H and E and F. So that's a good help there to getting the numbers or the letters in there to help you figure it out. Right, so we get cracking then. Okay, B/C D. Okay, I'm just going to pause this and write in all the letters. Now that done, I'm going to draw in my 45-degree line. I'm going to drop my points down from end elevation to my 45-degree line and bring them across the plan. So I'm going to just go ahead and do that. So that done, okay, now I'm going to focus on drawing the plan view. So these are dimensions. 8, so 8 is obviously multiplied by 4, the enlarged scale is 32, 28, so that's obviously 60 together, 60 there again, and then C is in 5, which is, okay, or sorry, no, point C is in 5 there, which is 20. Okay, so I'm going to set that out. So 120, okay, center line there, okay, 32, okay, and the 20 there for the opposite side. And then our 5 in from the side multiplied by 4 is obviously 20, then 32. Okay, and that's the end of it there. Right, so I'm going to project those lines up. And then, yeah, the width of it was 160. So I'm projecting these lines up. So here we have letter E, F, okay, then H, G, okay, I and J, and then K and L and D. Right, so I'm going to connect them together. Sorry there, my head hit off the visualizer. Now, so we have them done. Now we're looking to get, okay, point A, B, C, and D is already gotten. So B and C down there, and it's where C and B will be hitting the, okay, 5 multiplied by 4, 20, so they're in 20. So B and C down here, there's point C, there's point B, okay, point A is down across in the center, okay, and that's them joined together, okay, or that's them ready to be joined together. So I can join A to C, C to D, letter D. Oh, sorry there, what I should call that should be B. Okay, D to B, C to I, C to H, C to J. Right, there's surface C, surface B, surface A projects as an edge. Now, to draw the elevation, so I'm going to pause the video myself. I'm going to bring these points across from end elevation out the end view, and these points up from elevation. And then I'll mark them in with you. They're brought in or brought up and across. You can mark them in. Okay, A and D. Okay, E slash F. Okay, G. Okay, I. Okay, over here J and H. And then K and L. Right, now we're ready to mark them together. So K to D and L. Okay, L to J, C and H. L to sorry, not L to J, C and H. L to J. And have I, B and C marked in? I don't have B and C marked in, so I have to do that in. So here's B there. And then C is there across. Okay, now where was my train of thought there? Right, J to C, okay, C to H and H to J. So J to C, C to H, H back to J. Okay, and C back to D. Okay, C to A. Okay, A to B. B to D. B to G. G to I. I to K. And I to B. Okay, E to F as hidden detail. A to E. Okay, and then E to G and F to H. Oh, you fecker. Right, I'll have to fix that there. So there's surface A, B, and C. Now, part B, determine the dihedral angle between surfaces A and B. So, you have to look for line of intersection between A and B. Okay, here's the line of intersection in elevation. Here's the line of intersection in plan. You have to check, is the line of intersection a true length? Okay, in either plan and elevation. And it is a true length in elevation. So line DL is a true length because it's parallel to the XY line. Okay, in plan view. So I can look along that, okay, line of intersection DL immediately. So many students would, or so many people would try to look perpendicular again to DL, and it'd be immediately the same thing in elevation. So I'm going to look along line DL here in elevation, which obviously is unusual to most students because they're used to doing it looking along the line of intersection in the second auxiliary or projecting from the plan view. So I'm going to draw in a line parallel to DL from points K and J as well as D and L. I'm going to draw in an X2 or an X1 Y1 line. Now I'm going to take the distances from my XY line down to plan. Now I'm going to use a datum line because it would require a fair bit of room. So I'm just going to use this as a datum line. So I'm going to get my compass and I'm going to take the distances from the datum line down. So datum line down, D and L are going to project as a point. Just going to mark that in. That's D slash L. D1, and then I'm going to take the datum line down to J. Here's the datum line down to J. Lift, follow J here. Mark that in. That's J1, and then I need to get K. Okay, and that's going to be the same distance as D and L. I'm going to project mark from K. So there's K1. So there's surface A is an edge. Okay, here's surface B is an edge view. Okay, and then I'm going to measure the angle between them. So I'm getting 1, 4, 3. So 1, 4, 3. Okay, now part C. Okay, determine the surface development of surfaces A, B, and C. So this is the partial surface development, and remember what side. Oh yeah, you would have been able to see that dihedral angle. Hope so. Anyways, right. Remember what they give you on the question is your greatest hint. So look what they've done there. They've rotated surface A up, okay, until it's vertical, okay, and then they're projecting a view perpendicular to that, and there's the surface development. So part C is not too easy, or part C is easy enough rather, and then A and B we can find using triangulation, okay, by splitting the quadrilateral up into two triangles. Right, so I'm going to draw vertical line from D, and I'm going to take my compass, rotate B and C up onto that vertical surface, and then I'm going to project parallel to the XY line. Sorry. So they tell you a dimension of 10 and 10, so that's 40, or sorry, that's 20 in total, multiplied by 4, scale 4:1 is 80, so I'm going 80 in total. There's the center line. It's obviously going to be a square. Here's the fold line. Now, okay, so that's surface C. Alright, so that's A, B and C, and that's point D. So that's B, A, C and D. So we have D, okay, we have A up here, B and C. Okay, now we need points K and L, okay, on surface A. Now this is the true shape here in elevation because it projects as an edge in plan and the edge view of surface A is parallel to the XY line, aka the vertical plane. So D to K and D to L are already true lengths, and so too is K to L because it's parallel to the XY line in the plan. So to do surface A, I'm going to take, okay, D to L here. It's true length in elevation. This is what developments is about, being able to recognize what true lengths you have and how to find them. So I'm going to swing an arc with the radius of D to L, okay, radius of D to L there, right, radius D to L. Now, okay, somewhere along that arc is point L, but where exactly? Now I have point C on surface B, okay, and I can find, okay, sorry, what do I call that letter? That's going to be D, K, and then L, yeah. So I can find the true length of that line C to L. So what we're doing is splitting surface B, a quadrilateral, okay, into two triangles. So here's the line. Here's the line C to L in elevation. Here it is in plan C to L. I'll move my visualizer now. So I'm going to find the true length of that line C to L. So I can take my compass, rotate C to L in plan until it's parallel to the XY line in plan. I'm going to bring it up. Until it hits the XY line because L is on the XY line, and join back to C. Now here is the true length of C to L. So I'm going to take that distance with my compass, the true length of C to L, and I'm going to swing then from C. Now, there is point L on surface A, so I can join them together. Okay, now I can continue that arc. D and L and D to K are the same length, okay, because as they're symmetrical. So now to find out where K is, I can take L to K in elevation because it's parallel to the XY line in plan, okay, or I could take L to K in plan as it's parallel, it's on the XY line elevation. So I can swing that there from L and join D to that. Where that arc swung from L intersects this one, swung from D. Okay, that is point K. And I can join them together. Now, the next thing we have to do is find, okay, letter or final point on surface B, which is going to be point J, or the final letter on surface B, which is going to be point J. So I'm just going to join them together. So I need to find, okay, on surface B, point J. Right, so if I can get, I have point C, okay, if I can get the true length of, okay, what's that, L to J, and I can split this into a triangle as well, okay, D to J is the easiest way to find it. You could find the true length of C to J either, that's fine. I'm just going to, I think the longer the lines are, the quicker and more accurate it is. So I'm going to join D to J. I'm going to rotate D to J in plan until it's parallel to the XY line. In plan. So there we go. And here's the true length of D to J. So I'm going to take D to J there. I'm going to swing an arc from D. Now somewhere along that arc is point J. Now I can get the true length of line L to J. So I'm going to take line L to J. Careful not to mix it up with anything else. I'm going to bring this up then. So here's the true length of L to J. An alternative way you could find it is using an auxiliary if you feel things are getting a bit overcomplicated. So there's the true length of L to J. I'm going to swing an arc there until it intersects here. I'm going to join them together. Now, then we have to do the clock hand. Okay, so we're going to do that now. The clock, okay. Part D, the hour and minute hands are shown on the square watch in phase C in the development. Draw the hands on surface C in the development, view, and also in the elevation and plan. Right, so here's the radius of the clock. The small hand, okay, is a distance of 4 on our drone. So that's 16, okay, on our sheet, and then the minute hand is going to touch the base of the circle. Now, so there we are, there in our development view. Now what we have to do is rotate those points back on to the surface C in our end elevation. Okay, M, CP, and N. Put my compass on D. So I'm rotating them back. So there's point M, and there's point N. So I can drop these down, but they're not that easy to locate yet now. So they're not that easy yet. Okay, now we know these points are going to touch the center. So I'm going to call that X, or they can join to the center, and that point is on D. right? So D obviously join up to here. Okay, so N, to find N, so if I rotate, N joins the center point, and the center point there is in line with B, and across there's the center point of the face. It may not necessarily be in the face in plan view. We'll just move the visualizer a bit. Down across with N. Here's point N. Okay, now point M, okay, is not so easy to find, right? So I'm going to bring point X here over until it hits the end, rotate X down, right? That's letter X is on line A to B, so I'm going to bring letter X to line A to B in plan view. So there's letter X. And then that can join to the center point. Okay, and then letter M down across to touch that line. So there we go, and then we can project that up to our elevation. So here's letter M brought across. Letter M. There's the center of the face. Okay, and letter N. Now, there we go, and that was a good bit of fun. Cheers, thank you, bye bye.